Welcome to another lesson at EDU Solutions Institute. Now, today we're looking at the CSEC chemistry syllabus. And last week we focused on the mole concept, right? We delved into the basics of mole without talking about the mole. So we looked at the molecular mass, we look at relative atomic mass, we look at relative formula mass. Now, this week we're going to delve into the basic of the mole. So now let's go and explore what is the mole. A mole is not the animal, right? A mole is a quantity that tells us how much matter is present in a specific substance. Now, this specific substance is any chemicals that you can think of, anything that exists in nature, right? Now, it simplifies and tells us that if we quantify that 1 mole, it's going to represent a special number of matter, which are particles. And it tells us that 1 mole is equal to 6.02 times 10 to the 23 particles. And what that tells us is, just like volume, if we take the volume of a cup, right, and we have a specific cup, and we explore that irregardless of which liquid we put into this cup, the maximum it can hold would be this volume. So the mole is just like that. So the mole simplifies and tells us that if we want to know how much particles are in this remote, or how much particles are in this marker, if we quantify it and say this is 1 mole of the substance that make up this marker, then what we're telling the reader is that in this, scientists proves that there are 6.02 times 10 to the 23 particles that make up this object, right? So if it's half of a mole that this is quantified to be, then it will be half of this number. Now, this number is accredited to the Avogadro's law, and hence it is called the Avogadro's constant. So it tells us that we have this amount of particles in every mole of a substance. So anything that we quantify and say this is 1 mole, then it has this amount of particles. Now, what does the law say? What does Avogadro's law states? Avogadro's law states that under the same temperature and pressure, equal volumes of different gases, whatever gases it is, oxygen, hydrogen, nitrogen, carbon dioxide, whatever gas it is, it has the same number of particles, which would be that amount if it is 1 mole of that gas, right? So that's the basis on which we focus all our attention in terms of what is a mole. Now, at this point, what we're going to look at are the 2 formulas that we're going to use a lot in terms of calculating mole at this time, right? As we go along, we will include other formulas into the equation. Now, for any substance, we can find the mole of that substance if we have the mass of it. So therefore, if we have a container here of water, right, and we measure and know what's the mass of this water, and we get that the mass of the water is 50 grams, right? So therefore that quantifies that we know the mass of how much water is in this glass, right? Now, we know now that we did molar mass in our last session. So we know how to calculate the molar mass of water, which is, it has 2 hydrogens, so that's 2 times the mass of hydrogen, which is 1, plus it has 1 oxygen, and oxygen is 60. So therefore, the molar mass of water is 80. So therefore, to know that 50 grams of water will have this amount of mole, right? So what we just realized is that in every 50 grams of water, it will have 2 point amount of moles, and we put the mole at the end for the unit, or sometimes we abbreviate it as MOL, right? So that's how simple the use of the mole equation can be once we know the mass of the substance that we need to find the mole for. Now, what if it was a gas, right? Then it's hard to get what's the mass of a gas. So therefore, what we look at when it's gases would be the volume of the gases that's being present or being produced. So therefore, if we know the volume of the gas, whatever gas it is, and we know the condition that this gas is being mixed with or produced in, then we can find how much mole of the gas we have. So the two conditions for gases based on Avogadro's experiment and his law are the STP and the RTP. Now, the STP represents standard temperature and pressure, right? And the RTP is at room temperature and pressure. So what these two conditions tells us is that based on his experiment, whenever he did these two conditions, every single gas that you experiment on had something unique about it. It had that if we had 1 mole of any gas, then at STP, it will occupy a volume of 22.4 dm cube, right? Which sometimes it's good to know that it would be 22,400 centimeters cubed, right? So that's the amount of volume that any gas will occupy if it is 1 mole of the gas at standard temperature and pressure. And then at room temperature and pressure, RTP, he realized that all gases will occupy a volume of 24 dm cube, which would be 24,000 centimeter cube. Right? So these two numbers are very important because in the future we're going to use them, right? And it's always good to remember what they are, because in questions they would say this gas was experimented on in an RTP condition or STP condition. So hence you have to know which equation, which one of those constants we need to use. So for gases, to find the mole, we basically divide the volume of the gas by the value of the STP and the RTP condition based on which condition it is. Now, let's examine that if we have a specific gas, right? And we have carbon dioxide and we have 1200 cm cube of carbon dioxide at RTP. Then at RTP, then we have to use the corresponding unit of this gas. So we know that it's centimeter cube, so we use the centimeter cube value for RTP, which is 24,000. Right? So with 2 zeros cancel 2 zeros, this would go into this 2 times. So it would be 1 over 20, which would be 0.05. And the unit would be mole. So therefore, what this tells us is that carbon dioxide, 1,200 cm cube of carbon dioxide at RTP condition will be equivalent to 0.05 mole of carbon dioxide. Now, before we go, there is one last equation that we can actually focus on that will help us with the mole concept, and that is to include the Avogadro's number, right? So now we know that the mole is either mass over molar mass or volume of gas over the volume of gas at the different conditions. We also can see that the mole is equal to, if we know how much particles are present, over Avogadro's number. Right? So if we know that the glass of water has this amount of particles, or we know that it has this amount of atoms or this amount of molecules if it's a gas, then we can divide it by Avogadro's number and it tells us how much mole the gas or the substance has. So therefore we have learned 3 formulas that will help us going forward to examine and experiment and explore what the mole is. Right? So this is where we're going to stop. So I hope you understand a little bit about what is a mole. How do you calculate a mole in simple format? Because next week we're going to explore more and utilize these formulas in terms of writing chemical equations and using that relationship in our calculations. So until next week, enjoy and I'll see you next time.